Hi there, it's Professor Monty. We're looking at graphing systems of equations, the special cases, in terms of finding solutions to these systems. All right, and I'm just jumping in. We're going to give you two examples. We'll explain the two different special cases as we go. So solve graphically, we have these two. These are in slope-intercept form, so I'm going to graph both of the lines in slope-intercept form. The y-intercept here is 4. So we'll go up to 4, draw a dot. The slope is -2, or if you think of it as a fraction, -2/1, so down 2, right 1. Down 2, right 1. And then the graph's going to look something like this. The next graph, y equals -2x minus 1. So I go down to -1 is my y-intercept. I have the same slope, still down 2, right 1. Kind of missed that point. Let's draw that again. That was just not good. And what happens, notice, since these have the same slope, these two lines are parallel. Remember the solution to a system of equations, and I'll link my solving systems of equations graphically video to the end of this, but the solution is the points where these intersect. These never intersect. So anytime you have parallel lines that aren't the same lines, different y-intercepts, there's no solution. No solution. That's your answer. Why? Because they're parallel lines. All right, so anytime you have parallel lines, same slope, different y-intercept, no solution. Okay, now solve these graphically. Well, let's see, this time I've got a y-intercept of 4. Again, it's already set up in slope-intercept form, so I'll use that to graph it. I've got a y-intercept of 4. 1, 2, 3, 4. A slope of 3/2, so I go up 3, right 2. 1, 2, 3, 1, 2. There's my line. And now this one, not in slope-intercept form, I can plug in, find the x and y intercepts if I want to do it that way, but I'm going to have fractions for this one, so I don't really want to do that. I'm actually going to solve for y to get it in slope-intercept form. So let me go ahead and do the math there, a little algebra. Subtract 3x. I get -2y equals -3x minus 8. I'll divide by -2, divide each piece by -2. Y equals 3/2 x plus 4. I go to graph that, and it's same y-intercept, same up 3 and right 2. It's the same exact line. We see both equations are y equals 3/2 x plus 4, y equals 3/2 x plus 4. Remember, a solution is any point that satisfies both equations. Well, every point on that line satisfies every point. Now be careful, you can't say all real numbers, because for instance, this point doesn't satisfy it, this point doesn't satisfy it, this one. It's only the points on the line. Typically what they say, okay, we're going to say, okay, these are the same line, but same line's not my answer. Same line. My answer is usually written in this form. It's all points x, y, such that, and then just put in one of the equations. Y equals 3/2 x plus 4. Because what that's saying is any point that satisfies that equation satisfies the system, because both of these equations give us the same line. Okay, so that's the idea. This is often called inconsistent because there is no solution. And this one's often called dependent. But those are just names for it. Those are just words. The answer is no solution, or the set of all points such that, and then one of the equations. So be careful about what the equation are, what they're called, not the answer. The answer is what I have boxed. So be careful with those. Those are the two special cases that you'll run into when you're graphing to find systems of linear equations.